Alright, let's get into it. Number 10, Earth won the galactic lottery before it even formed. You think the habitable zone is just about being the right distance from your star. It is not. There is another zone, a much larger and far more unforgiving one, and it has nothing to do with your sun. It has to do with where your sun sits inside the Milky Way itself. In 2004, astronomer Charles Lineweaver and his team at the Australian National University published a landmark study in the journal Science. They modeled the entire evolution of our galaxy and found that the Milky Way has its own habitable zone, a narrow ring between roughly 23,000 and 30,000 light years from the galactic center. Earth orbits at about 26,000 light years out, almost dead center in this band, too close to the galactic core, and the neighborhood becomes a firing range. Our stars are packed so tightly together that supernovae detonate every few million years. A single Type 2 supernova within 25 light years would obliterate more than half of Earth's ozone layer, leaving every living thing on land exposed to lethal ultraviolet radiation. Too far out, and the galaxy becomes a wasteland of a different kind. Not enough heavy elements exist to build rocky planets in the first place. Carbon, oxygen, iron, phosphorus, all the atoms that make up your bones and your blood are forged inside dying stars and scattered through supernova explosions. In the sparse outer arms of the galaxy, there simply are not enough stellar deaths to seed the raw materials for a planet like ours. Think of the Milky Way as a massive highway. The inner lanes are a demolition derby where everything gets smashed. The outer lanes are an empty desert with no gas stations and no building materials. Earth's sun formed in the one narrow lane where conditions allow a rocky planet to survive long enough for something to crawl out of its oceans and wonder where it is. And here is the part that should bother you. A 2024 study from Kagoshima University showed that our sun likely did not even form where it currently orbits. It migrated outward from a position closer to the galactic center, drifting into the safe zone over billions of years. If the migration had been slightly different, a little faster, a little slower, a slightly different trajectory, Earth might have spent those critical early billions under the barrel of a supernova gun. Frown, your planet did not just find the right neighborhood, it drifted into it by accident, at precisely the right time, and stayed long enough for you to exist. Number 9, your star is suspiciously boring. Most people think the sun is ordinary. That is true. It is a G2V yellow dwarf, the definition of average. But that averageness is exactly what makes it suspicious, because in a galaxy where roughly 75% of all stars are red dwarfs, being average is being exceptional. Red dwarfs are violent. NASA's Kepler mission and the TESS satellite have shown that many of these small stars regularly release superflares, bursts of energy millions of times more powerful than anything our sun produces. Proxima Centauri, the closest star to our solar system, released a super flare in 2019 that was observed across multiple wavelengths and would have blasted any Earth-like planet in its habitable zone with radiation intense enough to destroy most complex organic molecules on the surface. A planet orbiting a red dwarf has to huddle so close to its star to receive enough warmth that it becomes tidally locked. One side permanently baking in eternal daylight, the other permanently frozen in eternal night. And those superflares would strip a planet's atmosphere like sandpaper against tissue paper. No atmosphere, no pressure, no liquid water, no life. Our sun does none of this. It has maintained a remarkably steady energy output for over 4.6 billion years. Its luminosity varies by about 0.1% over its 11-year solar cycle. That kind of consistency is profoundly rare. Many sun-like stars show far greater variability, and even small fluctuations over geological timescales can push a planet's climate past the point of no return. Imagine trying to grow a garden in a house where the thermostat randomly swings between 40 and 400 degrees Fahrenheit. That is what life would face around most stars in the galaxy. Earth got the one thermostat in the neighborhood that barely moves. The sun also sits in a relatively clean stretch of its galactic orbit between the Sagittarius and Perseus spiral arms in what astronomers sometimes call the local bubble. This means our solar system passes through fewer dense clouds of interstellar gas and encounters fewer gravitational disturbances than stars embedded in the arms themselves. It is as if someone deliberately parked our star in the quietest lane on the highway, On away from the pileups, away from the construction, in a pocket of calm that has lasted billions of years. The longer you stare at these numbers, the harder it becomes to call any of it random. Number 8. Earth's magnetic shield is cracking open. There is an invisible force field surrounding this planet. It extends tens of thousands of miles into space, and without it, everything you know would be sterilized within a geological eye blink. Earth's magnetic field deflects charged particles from the sun, traps deadly radiation in the Van Allen belt, and prevents the solar wind from slowly peeling away the atmosphere the way it peeled away the atmosphere of Mars. Mars once had oceans. Mars once had rivers. Mars once had a magnetic field. Then that field died, and so did everything else. But here is what most people do not realize. Earth's shield is not uniform, and it is not stable. In November 2025, the European Space Agency published the latest results from its Swarm satellite constellation, 11 years of continuous magnetic field monitoring, and the findings are deeply unsettling. Over the South Atlantic Ocean, stretching between South America and Southern Africa, there is a region where the magnetic field is dramatically weaker than everywhere else. Scientists call it the South Atlantic anomaly, and it has been growing. Since 2014, it has expanded by an area nearly half the size of continental Europe. The minimum field strength in the anomaly has dropped from about 22,430 nanoteslas to 22,094 nanoteslas. That might sound technical, but the implications are visceral. Satellites passing through this region experience computer glitches and sensor failures from charged particles that the weakened field can no longer deflect. Astronauts aboard the International Space Station report seeing phantom flashes of light behind their closed eyelids, cosmic rays passing directly through their retinas, whenever their orbit carries them over this invisible wound in the sky. Professor Chris Finlay of the Technical University of Denmark, who led the swarm analysis, noted that the anomaly is changing differently toward Africa than it is near South America, and the weakening near Africa has accelerated sharply since 2020. Deep beneath the surface, patches of reverse magnetic flux at the boundary between Earth's liquid outer core and its rocky mantle are driving this expansion. The global magnetic field has lost roughly 9% of its overall strength in the past 170 years. Is this the beginning of a full magnetic reversal where north and south swap places? It has happened hundreds of times before in geological history. The last complete reversal was about 780,000 years ago. Scientists say there is no evidence a reversal is imminent, but they also admit they cannot tell you for certain that it is not coming. Think of it this way. You live inside a house whose walls are slowly thinning, and no one can tell you whether the walls will stabilize or eventually disappear. That is where you are right now. The shield works. It has worked for billions of years, but it is not guaranteed, and the cracks are getting wider. Number 7. Liquid. Water is the universe's rarest luxury. Water is not special because of what it is. Water is special because of what it does and how absurdly long Earth has managed to keep it in liquid form on its surface. Most rocky planets either lose their water early, their gravity too weak to hold it against the relentless bombardment of solar radiation, or they never maintain the right temperature window to keep it liquid for any meaningful stretch of time. Earth has had vast, deep, liquid oceans for at least 3.8 billion years. That is not a minor accomplishment. That is a cosmic anomaly. Water is the single greatest climate regulator on this planet. It absorbs heat slowly and releases it gradually, smoothing out temperature extremes that would otherwise make the surface uninhabitable. It dissolves minerals, aquebeats, transports nutrients across entire continents through rivers and rain cycles, and allows complex molecules to interact without tearing each other apart. Earth's oceans are not just bodies of water. They are planet-sized chemical laboratories that have been running experiments for nearly 4 billion years. Early organisms could fail, mutate, and try again millions of times without being instantly wiped out by environmental instability. And the physics of ice plays a role so convenient it borders on suspicious. Ice floats. On almost any other substance in the universe, the solid phase sinks. If ice behaved like a normal solid, Earth's oceans would have frozen from the bottom up during every ice age, killing everything beneath the surface. Instead, ice forms an insulating lid on top, protecting the liquid beneath and the life within it. Muoik okay, isa anis. Every winter, in every frozen lake and every polar sea, life survives because water breaks one of chemistry's most basic rules in exactly the way life needs it to. And then there is the question of where Earth's water even came from. The early Earth was a molten hellscape, far too hot for liquid water. The leading theories suggest that much of our water arrived later, delivered by asteroids and comets from the outer solar system during a period called the Late Heavy Bombardment, roughly 4.1 to 3.8 billion years ago. The planet had to cool down enough for oceans to form, and then those oceans had to survive every catastrophe that followed. And in asteroid impacts that boiled portions of the sea, volcanic mega eruptions that choked the sky with ash, and ice ages that froze the surface from pole to pole. Through all of it, Earth held onto its water. Venus could not, Mars could not. Earth did. Take a step back and think about what this means. You need a planet at the right distance from a stable star, inside the right galactic zone, with enough mass to hold an atmosphere, with a magnetic field to protect that atmosphere. And then you need water, an enormous amount of water, to arrive from the outer solar system at the right time, survive billions of years of planetary violence, and remain liquid on the surface without boiling away or freezing solid permanently. Each of these conditions is individually rare. Together, they begin to look less like luck and more like something that should not have happened at all. Number 6. Jupiter is a bodyguard that might also be a hitman for decades. Astronomers assumed Jupiter was Earth's protector, a massive gravitational vacuum cleaner sweeping up asteroids and comets before they could reach us. The idea was popularized after comet Shoemaker-Levy 9 slammed into Jupiter in 1994, breaking into 21 fragments and leaving bruises the size of Earth across the giant planet's cloud bands. Objects roughly 10 meters in diameter hit Jupiter an estimated 12 to 45 times per year, compared to only once every 6 to 15 years on Earth. Jupiter, it seemed, was taking the bullets for us, but in 2016, planetary scientist Kevin Grazier at NASA's Jet Propulsion Laboratory published a study in the journal Astrobiology that complicated this picture considerably. Grazier ran simulations tracking tens of thousands of particles in the gaps between the outer planets for up to 100 million years. His conclusion was blunt. The widely reported shield role attributed to Jupiter is not accurate. The simulation showed that Jupiter, teaming with Saturn, actually kicks a significant fraction of small bodies into the inner solar system, placing them on orbits that cross Earth's path. Jonathan Horner at the Open University found something equally disturbing. If you remove Jupiter entirely from computer simulations, the impact rate on Earth barely changed at all. But if you replace Jupiter with a smaller planet about the mass of Saturn, the impact rate went up significantly. Jupiter both deflects incoming threats and redirects new ones. It is a bodyguard that occasionally fires into the crowd it is supposed to be protecting. What Grazier's study did suggest, however, is that Jupiter's most critical role may not have been shielding Earth at all. It may have been delivering volatile materials, water, and organic compounds from the outer solar system into the inner solar system during the chaotic early days of planetary formation. Without Jupiter's gravitational stirring, Earth might never have received the raw ingredients for its oceans and for life itself. So the same gravitational force that periodically flings comets at your planet may also be the reason your planet has water in the first place. The universe does not deal in clean categories. Your protector and your threat are the same object, and you exist in the narrow margin between the two. Number 5. Plate tectonics is the reason Earth did not die 4 billion years ago. Earth's surface is not a solid shell. It is a collection of massive plates grinding against each other, splitting apart, crashing together, and diving into the mantle. This looks destructive, and it is. Earthquakes, volcanic eruptions, tsunamis, all of it comes from plate tectonics. But without this process, Earth would have become either a frozen rock or a runaway greenhouse billions of years ago, and nothing would be alive to complain about the earthquakes. Plate tectonics is a planetary recycling system operating on timescales that dwarf human history. Volcanic activity releases carbon dioxide into the atmosphere, warming the planet. Over millions of years, that carbon dioxide is pulled back out of the atmosphere by chemical weathering of silicate rocks and trapped in sediments that are eventually dragged into the mantle by subducting plates. When the planet gets too cold, volcanism ramps up and releases warming gases. When it heats up, weathering accelerates and removes them. This carbon silicate cycle has kept Earth's temperature within a livable range for over 4 billion years. And an astonishing act of self-regulation on a planetary scale that no engineer has ever come close to replicating. Tectonics also dredge essential nutrients from deep within the planet. Phosphorus, iron, sulfur, trace elements, and spread them across continents and ocean floors. Life depends on these materials, and without tectonic recycling, ecosystems would eventually starve. The movement of plates also creates the environmental diversity that drives evolution. Mountains, valleys, coastlines, islands, deep ocean trenches, more habitats mean more evolutionary pathways. More biological experiments, more chances for complexity to emerge. What makes this deeply suspicious is how rare plate tectonics may actually be among rocky worlds. It requires the right amount of internal heat, the presence of liquid water to lubricate and weaken the crust, and a crust that is neither too thick to break nor too thin to hold together. Venus, despite being almost Earth's twin in size and mass, has a thick, stagnant lid instead of active plates. Its surface overheats until it catastrophically resurfaces all at once. A planetary seizure rather than a continuous healing process. Mars cooled too quickly, its small size bleeding heat into space until its interior solidified and its tectonics froze. Mercury never had the conditions to begin with. Even among the thousands of exoplanets discovered by Kepler and TESS, we have no way to confirm plate tectonics on a single one. It may be one of the rarest geological features in the universe. Earth somehow met all the requirements simultaneously and has maintained them for longer than complex life has existed. Your planet is not just alive with organisms. The planet itself behaves like a living system, and it has been performing surgery on its own climate for longer than any species on its surface. Number 4. The moon was born from an apocalypse that should have killed everything. About 4.5 billion years ago, a Mars-sized protoplanet called Theia slammed into the young Earth at an oblique angle. The collision was beyond catastrophic. It liquefied most of Earth's surface, vaporized rock into a superheated cloud of silicate gas that spread into orbit, and blasted whatever primordial atmosphere and ocean existed into space. From this debris disk, in what may have been a matter of hours, according to high-resolution simulations published by NASA's Ames Research Center in 2022, the moon formed, not over thousands of years, hours. The moon is unusually large relative to the planet it orbits, about 1/4 of Earth's diameter, a ratio unmatched by any other major planet-moon system in the solar system. That size gives it the gravitational power to stabilize Earth's axial tilt at roughly 23.5 degrees. Without it, computer models show Earth's tilt would wander chaotically over millions of years, potentially swinging by dozens of degrees. Polar regions would bake under direct sunlight for extended periods. Equatorial zones would freeze. Seasons would become violent, unpredictable, and unrecognizable. Long-term evolution, the kind that needs hundreds of millions of years of relative stability to produce complex organisms, would become nearly impossible. The moon also drives tides, and tides are far more important than they seem. They churn nutrients through the oceans, creating the dynamic coastal environments where life may have first crawled from sea to land. They generate rhythmic environmental pressures that push organisms to adapt, innovate, and diversify. The collision itself may also have been responsible for restarting Earth's internal heat engine, contributing to the convection patterns in the molten iron core that generate the magnetic field protecting the atmosphere you are breathing right now. Here is a terrifying coincidence. The impact had to be the right size, large enough to create a moon massive enough to stabilize Earth, but not so large that it shattered the planet into rubble. The moon had to form at the right distance, too close, and the tides would shred the surface too far, and they would be meaningless. The angle, the speed, the mass of the impactor, the composition of the debris change any single one of these parameters, and you get either a dead planet or no moon at all. Earth survived an apocalypse that should have ended everything before it started, and the scar that collision left behind is the one object keeping this world stable enough for you to exist. That is not luck. That is luck stacked on luck, compressed into a margin so impossibly thin that no one has figured out how to explain it. Number 3, the universe is calibrated to an impossible precision. Forget Earth for a moment. Forget the solar system. Forget the Milky Way. Step all the way back to the fundamental constants of physics, the numbers written into the fabric of reality itself, and the situation gets infinitely stranger. Physicist Martin Rees, the Astronomer Royal of Britain, argued in his book Just Six Numbers that the entire structure of the universe depends on just six dimensionless constants. One of these is the cosmological constant, which governs the expansion rate of the universe. Nobel laureate Steven Weinberg noted that this constant has a value roughly 120 orders of magnitude smaller than what particle physics predicts, a mismatch so grotesque it has been called the worst prediction in the entire history of physics. But if the cosmological constant were just a few orders of magnitude larger, the universe would have expanded so fast that no galaxies, no stars, and no planets could have ever formed. A few orders of magnitude in the other direction, and the universe would have collapsed back on itself within millions of years. The strong nuclear force which holds atomic nuclei together is calibrated to a similar degree. Make it slightly weaker, and atoms heavier than hydrogen cannot form. No carbon, no oxygen, no chemistry, no biology. Make it slightly stronger, and hydrogen itself becomes unstable, meaning no stars, no water, no fuel for the fusion reactions that power everything. So the gravitational constant sits in a range so narrow that shifting it by 1 part in 10 to the 34th power, the equivalent of moving less than 1 inch on a ruler stretching across the entire observable universe, would make life-sustaining planets impossible. Picture waking up in a hotel room where every detail has been calibrated for your survival. The temperature is perfect. The air pressure is perfect. The water is clean. The food is ready. The walls are the exact thickness to block outside radiation. You did not book this room. You do not know who did. But every dial, every setting, and every measurement is tuned to keep you alive. And changing any one of them by an undetectable fraction would kill you instantly. That is the universe you live in. 26 known fundamental constants, all balanced on a razor's edge. And no one, not a single physicist alive, can tell you why. The multiverse hypothesis says there might be trillions of universes with random settings, and we simply find ourselves in the one where the dials worked out. But that is not an explanation. That is a confession that the question has no answer. And unanswerable questions in a universe this precisely tuned are the most disturbing kind. Number 2, your atmosphere is a conspiracy 2 billion years in the making. The air you are breathing right now is not natural. It is the product of a biological conspiracy that nearly destroyed all life on Earth before it made complex life possible. For the first 2 billion years of Earth's existence, there was essentially no free oxygen in the atmosphere. The sky was filled with methane, carbon dioxide, and nitrogen. Then, around 2.7 billion years ago, a group of microorganisms called cyanobacteria evolved a remarkable molecular machine. The ability to perform oxygenic photosynthesis, splitting water molecules apart using sunlight, and releasing oxygen as a waste product. For hundreds of millions of years, this oxygen went nowhere. It was immediately absorbed by dissolved iron in the oceans and by minerals in the crust. The planet soaked it up like a sponge, but cyanobacteria kept producing it. Generation after generation, for hundreds of millions of years, these microscopic organisms pumped out oxygen that the planet kept swallowing, until around 2.4 billion years ago, the sinks finally ran out. The iron was consumed, the minerals were saturated, and oxygen began flooding the atmosphere in what scientists called the Great Oxidation Event. Or for the anaerobic life that dominated Earth at the time, organisms for whom oxygen was a lethal poison, this was the apocalypse. It was a mass extinction event so thorough that some scientists have called it the oxygen holocaust. An entire biosphere was wiped out by the waste product of another form of life. But here is where the conspiracy deepens. Oxygen is a highly reactive element. Left to its own chemistry, it quickly bonds with rocks and metals and vanishes from the atmosphere, which is exactly what happened on Mars. On Earth, oxygen only persists because living organisms continuously replenish it through photosynthesis. Life maintains the atmosphere, and the atmosphere supports life. This is a feedback loop so delicate it has no business being stable, yet it has held together for over 2 billion years. The oxygen also reacted with ultraviolet radiation to form the ozone layer, TR, the shield that blocks the UV radiation that would otherwise sterilize the land surface. Without ozone, life could never have left the oceans. Everything on land, every tree, every insect, every mammal, every human being exists because a microbe's waste product built a radiation shield in the sky. MIT researchers traced the ancestry of all modern cyanobacteria to a common ancestor that evolved around 2.9 billion years ago, meaning the biological machinery for this entire atmospheric transformation was in place 500 million years before it actually triggered the event. Why the delay? Recent research suggests that high levels of nickel and other compounds in the early oceans may have suppressed cyanobacterial growth for hundreds of millions of years. Another study published in Nature Geoscience found that the length of Earth's day played a critical role. When the planet spun faster, days were too short for oxygen to accumulate and escape the microbial mats into the water column. As the moon gradually slowed Earth's rotation and days grew longer, cyanobacteria gained enough daylight hours for oxygen to finally build up and break free. It took that long, 500 million years of invisible preparation for conditions to align. Your atmosphere is not a feature of the planet. It is a living system, maintained by organisms that have been running the same chemical cycle for longer than any mountain range, any continent, any ocean basin has existed in its current form. If photosynthesis stopped tomorrow, free oxygen would vanish from the atmosphere within a few million years. Waking. The air you breathe is borrowed time, and the only thing keeping it here is a chain of biological processes that began before the first animal ever opened its eyes. Number 1. The uncomfortable conclusion. Here is the problem. You can explain any one of these factors as coincidence. Earth landed in the galactic habitable zone. Lucky. It orbits a stable star. Fortunate. It has a magnetic field, liquid water, plate tectonics, a stabilizing moon, a complex atmosphere, and a set of fundamental constants tuned to permit atoms, chemistry, and stars to exist. Each one, taken alone, is improbable but not impossible. Stack them together and the math becomes something else entirely. Physicist Roger Penrose once calculated the odds of the universe having the specific low entropy initial conditions required for its current state. His number was 1 in 10 to the power of 10 to the power of 123. That is not a number your brain can process. It is not a number any human brain can process. It is a probability so vanishingly small that writing it out in standard notation would require more digits than there are particles in the observable universe. And Penrose was not even talking about life. He was talking about the universe simply existing in a form where structure is possible at all. Galaxies, stars, planets, anything other than a featureless soup of radiation and entropy. Now, layer on top of that every condition discussed in this video. The galactic address, the stellar temperament, the magnetic shield that is quietly cracking beneath your feet, the oceans that have been liquid for nearly 4 billion years while every other rocky planet in our solar system lost theirs, the gas giant that both protects and threatens, the tectonic engine that recycles a planet's chemistry on billion-year cycles, the moon forged in a collision that should have been fatal, the 26 constants calibrated to tolerances beyond human comprehension. The atmosphere maintained by microorganisms that have been running the same chemical program since before animals, before plants, before anything with more than one cell existed on this planet. Each factor supports the others. Water helps regulate climate, the atmosphere protects the water, the magnetic field protects the atmosphere, plate tectonics regulate temperature, the moon stabilizes the tilt. Remove any one of these, and the entire structure weakens or collapses entirely. This is not a list of separate coincidences. It is a single interlocking system, and every piece depends on every other piece being exactly what it is. The multiverse says we are just one of countless rolls of the cosmic dice, and we happen to be in the universe where every die came up right. The simulation hypothesis says someone or something built this. The anthropic principle says we can only ask this question in a universe that permits us to exist, which is true but explains absolutely nothing. It is a tautology dressed up as a theory, and the fine-tuning problem just sits there, unanswered, uncomfortable, staring back at every physicist who has ever tried to make it go away. No telescope can resolve it, no equation can dissolve it. It simply persists, like a question written into the structure of reality itself. The uncomfortable possibility is not that Earth is one of many, it is that Earth might be one of almost none. And if that is true, then everything alive on this planet, every cell, every bacterium in a hydrothermal vent, every whale singing in a dark ocean, every conscious mind staring up at the light of dead stars and trying to decode the patterns is not just rare. It is so improbable that the word miracle starts to feel like an understatement, even for people who do not believe in miracles. You are the universe looking back at itself, and you exist because of a chain of conditions so long, so fragile, and so precisely calibrated that breaking any single link would have erased you before you began. And the most unsettling part is not that you exist against impossible odds. It is that you will never know whether those odds were beaten by accident, by design, or by something your species does not yet have the language to describe. Sleep well. I'll be sharing more similar videos in the future, so subscribe to stay tuned.